Welcome class 6. Today in our mathematics the topic of discussion is least common multiple. Now it is also known by short form LCM. L stands for least, C stands for common, M stands for multiple. Now you have the definition over here given, but I would rather explain to you by example. Okay, you have one example over here. Two numbers are there, 2 and 3. They have asked us to find the least common multiple of 2 and 3. So you remember what are multiples? Multiples of a number are those numbers which comes in its own table, like 2 zeros are 0, 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 5s are 10, 2 6 are 12, and so on and so forth. It goes on. There is no end of multiples. You remember? We can go on. It even goes on after 2 10s are 20, 2 11s are 22. Similarly, multiples of 3 are those numbers which comes in its own table, including 0. 3 zeros are 0, 3 ones are 3, 3 twos are 6, 3 threes are 9, and so on and so forth. And they have given dot dot dot. It means they go on. So just like in finding HCF, in LCM also we will find common, those multiples which are common to both of them, to both 2 and 3. So which are those multiples? You have 0 common, as you can see. Next you have 6 common, and then 12 is common, and if you go on you will find that there is 18 also common. Okay, in course of 2's multiple you will get 2 9s are 18 also, no? And here also you have 18 in 3's multiple. So this also will go on. Common multiples, you will have infinite number of common multiples, because there are infinite number of multiples of both the numbers 2 and 3. But we are not interested in writing all the multiples. In fact, we cannot write. What we are interested in, finding the smallest among all the common multiples. In HCF we used to find the highest or the greatest common factor, but here we will find the smallest. So 0 will not be the smallest. Apart from 0, because 0 is no value, no? So we cannot have 0 as a common multiple. So leave 0. In fact, in this writing multiples, you can omit 0. You can directly start from finding 2 1s are 2, 2 2s are 4, 2 3s are 6, and for 3 3 1s are 3, 3 2s are 6, this is 9, 3 4s are 12. This 0 no need to write. So apart from 0, which is the smallest among the common multiples, 6. Apart from 0 you have 6. So LCM, or least common multiple of 2 and 3, is 6. So this is the meaning of LCM, least common multiple. But we don't use this method, okay, for finding LCM. The most preferred method of finding LCM are prime factorization method and division method. These are the two methods. First, let us discuss prime factorization method. And this also I will explain by an example. Now we have 3 numbers and we have been asked to find LCM of these 3 numbers. So just like in finding HCF, we used to use prime factorization. So for this also we will find prime factorization. So prime factors of 8 are here done for you. 2 4s are 8, 2 2s are 4, 2 1s are 2. The moment you get 1, we stop. So 2 into 2 into 2. So here prime factors of 8 are 2 into 2 into 2. Similarly, prime factors of 12, 2 6 are 12, 2 3 is 6, 3 1 is 3. The moment you get 1, we stop. So what are the prime factors? 2 into 2 into 3. So prime factors of 12 are 2 into 2 into 3. Similarly, prime factors of 18, 2 9s are 18. Similarly, 3 3s are 9, and then at the end 3 1s are 3. So which are the prime factors of 18? 2 into 3 into 3. So Here they are, 2 into 3 into 3 are the prime factors of 18. Okay, just like in HCF, we will not do in LCM. What we used to do in HCF, we used to write only the common, but here we will not write common, we will write all of them. That also, like see over here, 2 is given here 3 times, here 2 is only 2 times, here 2 is only 1 time. So as I said, we don't write common, we write all the factors. So which are the factors? We have the number 2 and the number 3. There are no other numbers apart from 2 and 3. But that value of 2 we are going to write, which is repeated the maximum number of times. 2 is repeated 3 times. So we will write 2 3 times. Similarly, 3 over here only 1 time, over here 2 times. So how many times maximum 3 is repeated? 2 times. So 3 will be written 2 times. Okay, and then we multiply. Okay, once again I am saying we write all the factors in this LCM, and that also the maximum times, how many times it is repeated, that many times we write that factor. Like 2 is maximum repeated 3 times, so we will write 2 3 times. 3 is repeated maximum 2 times, so 3 we are going to write 2 times. And at the end we multiply. 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 3s are 72. So our required LCM is 72. Similarly, we have another example over here. Now this time I am not going to write separately how to find the prime factors. You can do that by yourself. 36, 75 and 80. These are the 3 numbers whose LCM we have to find. So prime factors of 36 are 2 into 2 into 3 into 3. Similarly, prime factors of 75 are 3 into 5 into 5. Prime factors of 80 are 2 into 2 into 2 into 2 into 5. Remember, while finding prime factors, we use the smallest possible table. Okay, so and all the factors should be prime numbers. Okay, no other number apart from prime numbers. So now when we find the LCM, as I said, we write all the factors. So how many factors we have? We have the number 2, we have the number 3, and then we have the number 5. Starting with 2. 2 repeated here 2 times, there is no 2 over here, and 2 is repeated here 4 times. So what is the maximum number of times 2 is repeated? 4 times. So that 4 times value of 2 we write. So 2 is multiplied 4 times. 3 here is multiplied 2 times, here only 1 time, and here we don't have any 3. So what is the maximum number of times 3 is multiplied? 2 times. Okay, so here we have 3 2 times. Next comes 5. 5 here 2 times given. There is no 5 in this case, and 5 here only 1 times. So what is the maximum number of times that 5 is multiplied by itself? 2 times. So that 2 5s we have written over here. Okay, so we write the maximum value of all the factors or all the multiples in this case. So here, I mean, no, it's not multiples, sorry, they are factors only, prime factors. So maximum times any factor is repeated, that many times we repeat. So finally we multiply 2 into 2 into 2, 2 to the 4, 4 to the 8, 8 to the 16, 16 3 is a 48, and then 48 into 3 is something, that into something, at the end you get 3600. So the LCM is 3600. So this was your prime factorization method. This is how you do or find LCM using prime factorization method. Next method that is there is our division method. This is very popular method also. Now in this method, like in this case, we are supposed to find the LCM of 18, 24, 36 and 45. All the numbers are written together. Okay, like how you used to find prime factors here separately, for 8 separately, for 12 separately, for 18 separately. Here we combine all of them and write, and then we factorize them in a combined manner. But there is a rule for finding LCM in this combined manner. it is not possible every time to find one table which can divide all the numbers. Right now 18, 24, 36 and 45 cannot be divided with 2's table. 45 does not go with 2's table. So what is the rule? That at least any two numbers should go with one table. So in this case, we see that 18 will go with 2's table, 24 also will go with 2's table, 36 also goes with 2's table. So the rule is at least two numbers should go with one table, but here three numbers are going, so it's fine. So we write 2 9s are 18, 2 12s are 24, 2 18s are 36. But 45 does not go with 2's table, no? So write that 45 as it is. As it is, we write down 45 in this column also. In this row also. So next we have to find which number can divide 9, 12, 18 and 45. So since we were continuing with 2, let us see if we can continue with 2 for this particular row also. What's the rule? That any two numbers among this row should be able to be divided by that particular number that we have chosen. So we see 12 and 18 are those two numbers which can go with 2's table. So 2 6 are 12, 2 9s are 18. But what about this 9? Does 9 go with 2? No. So 9 will be written down as it is. What about 45? 45 does not go with 2's table, isn't it? So 45 again will be written down as it is. Okay. Now in this row we have 9, we have 6, we have 9, we have 45. There is only one number which will go with 2's table, that is 6. But that goes against the rule, no? At least there should be two numbers which should go with any table. So with 2's table not possible, so we have taken 3's table. With 3's table we have 9, 6 and 45 that will go. Okay. In fact all the numbers will go, With 3's table all these will go. 3 3s are 9, 3 2s are 6, again 3 3s are 9, 3 15s are 45. Okay. So we get a new row in which we have 3, 2, 3, 15. Again we'll continue with 3's table also. With 3's table 3 1s are 3, 3 1s are 3, 3 5s are 15. This 2 doesn't go. So 2 will be written down as it is. Now in this row, let's find any table which goes apart from 1, okay? We can't choose 1. With 2 you have only one number that goes with 2. With 5 we have only one number that goes with 5. And 1 we cannot write. So there is no other table which will divide any two numbers, that is apart from 1. So we stop over here. This process of finding the prime factors stops over here. Now how to find the LCM? We find LCM by multiplying first the vertical section, then the horizontal section. These numbers which are left in the last row. This is the last horizontal section that will also be multiplied. So first we multiply the vertical section. Vertical means the standing. Okay. So 2 into 2 into 3 into 3. Here 2 into 2 into 3 into 3. This is the vertical section. Next comes the horizontal section. In that we don't multiply 1. Okay. Any number multiplied with 1 will give the same number. So there is no need for multiplying with 1. So in the horizontal section we have only 2 and 5. Here 2, 5. Okay. So the LCM will be the multiplication of the vertical section and the horizontal section. So it comes 360. This is the LCM by using division method. Okay. Now I want to teach you how to find HCF by using this particular method only. Okay, by this particular method in this book they have given how to find LCM, but what is not given in this book is that we can actually find the HCF of these four numbers also by using this method. Okay, I'll show you. Now to find HCF we write all the four numbers like this in one row and then we factorize. But unlike our LCM where at least two numbers should go with one table, in this all the numbers should go with one table. Okay, all numbers should go with one table. So with 2 it is not possible to divide all the numbers because this is 45 which does not go with 2, but we can use 3's table and divide all these 4 numbers. Let's try. So it is seen that 3 can be used to divide all the 4 numbers. 3 6 are 18, 3 8 are 24, 3 12 are 36, 3 15 are 45. Next, let us find or try to find another table which can divide 6, 8, 12 and 15, all of them. We don't have any such table. If you use 3, 3 will divide 6, 3 will even divide 12 and 15 also, but 3 doesn't divide 8. If you think of using 2, 2 will divide 6, 2 will divide 8, 2 will divide 12 also, but 2 will not be able to divide 15. So there is no other table which will divide these numbers, all these 4 numbers. So we stop. And so now our turn to find HCF. How do we find HCF? Now to find HCF, we only multiply the vertical section, and we have only one number in the vertical section. We don't use the horizontal section. So our HCF of 18, 24, 36 and 45 is 3. Only 3. Because 3 is the only number that is there. Had we got one more table which could multiply all these 4 numbers, then another number could have been there that we could have multiplied with 3, and then that would be our HCF. But that is not possible in this case. The vertical section has only one number, 3. That is our HCF. So HCF of 18, 24, 36 and 45 is 3.